Hello and welcome to another video. In this video we're going to be working on count number of nice subarrays. And in this one you're given an array of integers nums and an integer k. And a continuous subarray is called nice if there's k odd integers in it. Return the number of nice subarrays. So here they show you which ones you have. So basically you need to have 3 ones in it. So here's one of them and the other one is like this. In the second one there are none. And in the third one, there's a lot. So let's go through this third one, and I'm going to show you how to do a 3-pointer sliding window. And basically, every 2-pointer sliding window can be, you can use a 3-pointer sliding window, but most of the times it's not necessary. But generally, what a 3-pointer sliding window allows you to do is, let's say you have some window with 2 pointers. So you basically have like a valid window like this. And this first pointer tells you like what's the smallest window where this is valid, and then you have one more pointer that says what's the biggest window where this is valid. So this means that all windows from here to here are valid. So like this is valid, this is valid, this is valid, this is valid, and this is valid. And that's kind of the idea. And if we have these 2 pointers, so we know like for like this is valid and all of these are valid, we can easily figure out like if this is the end of our window, if these are all the valid ones, we could figure out how many there are. So we could say like given an end of an array, how many different starts can you have? And that's kind of how you can do it. So let's walk through exactly what we're trying to do and how to use these 3 pointers. So the idea is our window is going to contain the minimum and maximum valid window ending at some index where the number of odd numbers is k. Now sometimes you'll have less than k, but it will never be bigger than k. So let's walk through how this will work. So we'll have 3 pointers, maybe we'll use like different colors. So let's say the right window is green. And then let's say the left window is white, or let's use brown. And the middle one is pink or something. So basically the idea here is we're going to shrink our window anytime we have more than k odd integers. So in this case, there aren't more than k. So I guess we can make this, we can make it so there are. So I guess maybe let's just change this to a 1. And let's use a different example. So here, there are going to be cases where you have more. But let's walk through how this goes. So you're going to have a result, which is like the number of subarrays, and we'll make that 0. So as you build your window, first we're just going to build our window until our number is bigger than k. Actually, we're going to build our window until our number is equal to k. So we're just going to leave this middle and this left on the left, and we're going to have the right just like a normal sliding window. So we're going to grow our window until our number is k. And we're going to keep track of that in a variable. Let's call that like odds or something. So here we have 0 odds so far, so we can keep going. 0 odds, 0 odds. Here we have 1, but we're going to basically build it until we have 2. And this is kind of the interesting part. So now we actually have 2 odds. So now what we need to do is we need to determine what's the minimum window possible where we have 2 odds. And then if we have the minimum and maximum window possible where we have 2 odds, we know that if like this is the minimum window and this is the maximum window, that means all of these are valid subarrays, right? And we can easily get the count of that because you'll just have a pointer here and a pointer here, and then you can figure out like how many different indices can these be, and this is just going to be this index minus this index plus 1, right? So like this is a subarray, this is a subarray, this is a subarray, this is a subarray. So let's walk through kind of the logic here. So now that we know we have 2 odds, we're basically going to take our mid pointer and we are going to keep moving it forward until we get to an odd number. And then once we get to an odd number, we know that if we keep going, that means we won't have enough anymore, right? So k is 2. So we need our mid pointer to be on an odd number. So we're going to keep moving it forward up until this point. And now our left will be the biggest window possible that's still valid, which is this whole thing. So that means that this is our mid, this is our left, this is our right, and now everything's in the perfect spot, and we have 2 odds exactly. So now how many arrays can we make with this being the end? Well, it's just going to be this index minus this index plus 1, right? Because like if you just count subarrays from here to here, this is valid, this is valid, this is valid, this is valid, 4 of them. Now, the reason you often get away with a 2-pointer sliding window is oftentimes if you just keep track of like the shortest array possible, then maybe like anything longer than that is also possible, and then you can just get that in O of 1. So like there's a lot of problems that are like this is possible, and then if you know this is here, that means anything from the start to here is also possible. But in this case, that won't be the case. That's why you need 3. So here, these are, this is basically like, how many do we have here? So we have 4, right? So it's just going to be the number of possible subarrays is the middle pointer minus the left pointer plus 1. Kind of like right minus left plus 1, right? But now we're asked for the number of subarrays, so it's just all the different, all these different ones. Okay, so now let's keep going. So now here, this is even, so the number of odds stays the same. And so we, once again, this has to be on an odd number, and if we move it forward, then we're going to have 1 odd. So this is in the right spot, and this is also in the right spot. We're only going to move the left pointer once we once our window is too big to actually shrink. But so far our window's fine. Like we have 2 and we want 2. So here, how many subarrays do we have? So it's the same thing. For this end index, we have 4. So 8 total. Now we come over here. Now, the number of odds we're keeping track of is in this whole thing, not this small one. Well, actually, it's going to be the same, right? This is the minimum window possible where it's at, and this is the maximum window possible where it's the same. So odds will be the same in both of these. So now we have 3 odd numbers. So we need to shrink our window. So this is the other thing, is how do we shrink the window? So what we can actually do to shrink the window is we know like our mid will either be the same place as the left or ahead of it. So we'll just say, let's just take our mid and shrink it until we have a valid window, and then let's just make our left go to where the mid was. You can move them both up, but it's unnecessary. So basically we're going to move this mid up until we have 2 odds. And the other thing is, the nice thing about that is, you remember our mid was on an odd number already, so all we have to do is move it up 1. Right? So we move the mid up 1. Now we have 2 odds. Now this is the maximum valid window. So now we could throw our left over here because this is the maximum valid window. Now we're going to keep moving the mid forward again until we get to an odd number. So we're going to move it up to here, because if we move it up any more, then we'll have less. Right? So the idea is to shrink. You just move the mid up 1. You move the left where the mid is, and then you keep moving the mid up again until you get to another odd number. And you can't move it up anymore because then you'll have less than k. So now we do the same thing. Like this is the minimum valid window, this is the maximum valid window. How many subarrays do we have? Just this guy minus this guy plus 1, so we have 3 more. Then we move this up. And notice if it's basically, I guess, some shortcuts that I didn't use, but I'm going to use those is, in this problem, is if we are on an even number, we don't really have to do anything, right? If we're on an even number, we're never going to move these at all. So if we're on an even number, we don't have to move anything. We just check, do we have k? And if we do, we do this. If we get to an odd number, then depending on if we have more than k, we have to shrink our window. Sometimes we do, sometimes we don't. But no matter what, if we get to an odd number, actually no. So yeah, if you get to an odd number, you might have to shrink the window. If you get to an odd number that's less than k, you don't really have to do anything. And then if you get to a, yeah, so those are basically the cases, right? If you get to a number that's bigger than k, you have to shrink the window. If you get to a number that, if it's still less than k, then you don't need to do anything either, right? So if you're still less than k, you just keep all your stuff the same because you're not gonna like do anything there. The only time you really need to do anything is if you're on k exactly and you are on a number greater than k. So when you're on k exactly, you're going to move your mid pointer to be on an odd number, and when you're on greater than k, you're just going to move your mid pointer to go to the next odd number. You can make it faster probably by using like a hash map if you want to, but it's not necessary, so this will be an O of 1 solution. So now we're basically done, so we have 11. So I guess we can write this down, like all the different things. So if we're on an odd number, so even basically do nothing, right? Like all we have to do is move this up, and then we just calculate if our number is, if we have k, then we just take this result and we add it to our current thing. So we still have to do that, but that's about it. And then if we are on an odd, if we're on odd number, if our odds is greater than k, then all we have to do is just move our middle pointer up 1, right? Because it's on an odd number. So if we move it up 1, it'll be on an even, and then move the middle, or move the left pointer to go where middle is. And then the other thing you have to do is you have to, so actually that's it. And then the other thing is if odds equals k, then just make sure to move middle to closest odd. And that's pretty much it. So maybe it's a little bit confusing, but it'll be easier in the code. And yeah, so it's 3-pointer sliding window. You can practice it. You can do this in a lot of problems, but like I said, normally there's a shortcut to get rid of the 3rd pointer. So let's code that. So we're gonna have this like left. We're gonna have a middle. And then our right will just go through the loop. And then we'll have like the number of odds we have. And we need a result. Okay, so now we just loop through nums like a normal sliding window. So for int right equals 0, right is less than num's length. And there's a bunch of ways to code up the 3-pointer one. It's kind of variable to whatever you want. Okay, so first we're gonna check if we have an odd. So this is pretty easy. We can just say odds plus equals nums are mod 2. That way if it's odd, we'll add 1. If it's 0, we'll add nothing. Okay. So now, if we can check if our number is bigger than k, all we have to do is move the mid up 1 because the mid should be on an odd number already, assuming we did everything correctly, and then move the left where it is. So we can just say mid plus equals 1, or plus plus, left equals mid, and odds minus equals 1, like this, actually. Okay, there we go. So now, if our number of odds is exactly k, our mid pointer might not be in the right spot. So if our odds is exactly k, like if you think about it, like we started over here, right? So once we get here, we didn't really move anything. So if our number of odds is exactly k, we need our mid pointer to be on an odd number, because that means if you move it 1 more, it'll go out of bounds. So basically the idea is, I guess we can get rid of all this. The idea is we don't have to move these two until odds is exactly k. When odds is exactly k, you leave the back one where it is, you move the mid one on an odd number. And then once you get to a number bigger than k, like over here, then you just move the mid up 1, and then you move the left over here, and now it'll be exactly k, so then you move it to the next odd number. So hopefully that makes sense now. Maybe I explained it kind of badly in the message there. Okay, so that's let's see. Left equals mid. So we only have to do this if actually we have to do this if odds is greater than k, or it's basically going to be k plus 1. So this is what we have to do here. Now we have to also, while odds equals k and mid is not on an odd number, we just keep moving it up. You can make this faster with the hash map, but it's still going to be O of n, so it doesn't really matter. So while odds equals k and nums mid is not on an odd number, then we just move up our mid pointer. The left pointer should be in a valid location. It should be like the end of the window, like the widest end of the window. Now all we have to do is check if odds equals k, then we just increment our result. And we increment our result, remember, by mid minus left plus 1, because those are all the valid locations for the left end of the subarray. So hopefully that makes sense. Like I said, many different ways to write this, but this is pretty clean, I feel like. Let's see. So if odds greater than k, let's see what we got. Oh, it's because I used left. Hopefully that's correct. Yep, nice. So you can clean this up like as much as you can. I feel like this is as clean as it gets. Like we're moving our pointers as little as possible logically, so I think this is pretty good. So hopefully this makes sense. Now the constraints, like the way you move your pointers are going to vary problem to problem. Like you probably can't always like move your mid just one, and you can't like jump to your mid and so on, but you can kind of like, worst case scenario, you can basically like have a couple while loops. You have one while loop for your left and while loop for your mid, but I think this is like as clean as it gets for this problem with all the shortcuts I can think of. So here, and yeah, I think you can do like a hash map of all locations of all odd numbers as well, and then you can like jump your window, or like I could see having like a sliding window and you have a hash map of all locations of all your odd numbers, or maybe like the last odd number, something like that might work, some kind of thing like that. But this is pretty good as well. And this is a generic solution you can have to like any problem where you need to know like what's the minimum window possible and the maximum window possible. So I could figure out the number of different subarrays ending here, an O of 1. So this is going to be an O of n solution and a O of 1 space. And this is a pretty rare algorithm. Like I think I've done it in like 2 or 3 problems. But once you see it, it's not too bad to execute. You just realize like, okay, this is the minimum window possible, this is the maximum window possible given this end index. Then it's kind of intuitive and you can use it in a lot of other problems. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.